just going to be dealing with using some decimals. All right, the last example, guys, that I had at least prepared, and then I will check in with the chat because I haven't really gotten to the chat since the beginning. It's just talking about the vertical and horizontal asymptotes. So kind of going back to our original problem, which is a good idea. What was that problem? 2x squared plus 5x minus 3. Okay, so I have 2x squared plus 5x minus 3. Okay, so let's go ahead and identify, let's just say if this was x, what was it, 2x plus 3, so let's just do x, I don't know. There we go, plus 7. Okay, so in this case, to find the, what was it? Hold on a second. I just forgot my brain hurts. X plus 3 to x minus 1. Okay. X plus 3, I'll just do that. Okay. So in the first example, if I had this, so if I had an example like this, and I said, find the vertical and horizontal asymptotes. The first thing we want to do is find the vertical asymptotes, and that's going to be the values that's going to make the denominator equal to 0. However, we want to make sure that that value is not going to be divisible into that. So we want to make sure we can factor that, right? Now, again, we already know our answer here. So we know that x plus 7 does not divide evenly into our numerator. So therefore, we can say that when x plus 7 is equal to 0, that's going to be a discontinuity. It's not going to be removable because it cannot be divided out. And therefore, it's going to be a vertical asymptote. Okay. If it does divide into it, then it would be a whole, which we'll talk about in a second. But anyways, we're going to have x equals -7 is our vertical asymptote. Our horizontal asymptote, whenever the degree in the denominator evenly divides into our numerator, then we're going to have no horizontal asymptote. So when our degree in our denominator is smaller than our degree in our numerator, then we're going to have no horizontal asymptote, and therefore I'd either want to look for holes or for slant asymptotes. Now in the next example, let's say I had 2x squared plus 5x minus 3 divided by x squared plus 3x. Okay, now again, in this example, I'm going to want to simplify this. So I already know my answer in the numerator, 2x squared times x plus 3, all over x times x plus 3. Now in this case, you can see that x plus 3 divides into it, right? So even though x plus 3 is or x equals -3 is a discontinuity, like that makes the denominator equal to 0, it's a whole. So I can say at x equals -3 is not a vertical asymptote. That is a whole. However, x is still in the denominator. So when x equals 0, that is going to be my vertical asymptote. So again, that's the idea of the removable that can be divided out or the non-removable discontinuity. The other thing that's interesting is my degrees, the degree in the numerator and denominator are the same. So when the degree in the numerator and denominator are the same, then my horizontal asymptote is going to be the leading coefficient 2 of the numerator over the leading coefficient of the denominator 1. So that's going to be y equals 2 over 1, which is just 2. All right. And then the last example is, so I guess I do my examples like this. Okay. Last example is, what if I had 2x squared plus 5x minus 3 all over x cubed? Oh, here, let's just do, no, why don't I do this? Why don't I do a 2x minus 1? No, sorry, I'm an idiot. What am I trying to do? Let's just do what I was originally going to do. Let's just do x cubed. So again, we notice that nothing's going to divide out this x cubed, right? You could factor this out, but like nothing's going to divide out. But again, it's still kind of helpful to like look at it that way. Okay. So again, nothing divides out like it did up here. So therefore my vertical asymptote in this case is going to be at x equals 0, right? Because when x is equal to 0, that makes the denominator 0. So therefore the value is undefined. As far as horizontal asymptotes, again, we're going to be looking at the degrees. Since in this case, the degree of my denominator is larger than the degree of my numerator, my horizontal asymptote is going to be y is equal to 0. So to kind of summarize, when you're looking to identify the vertical asymptotes, you basically just want to set the denominator, equal to 0 and solve. You just want to make sure that your denominator or whatever factors you have does not evenly divide into this numerator, because then that's going to be a whole, a removable discontinuity rather than a non-removable or an asymptote. As far as the vertical or horizontal asymptotes go, you're basically just going to be comparing the degrees. Either degree in the numerator is going to be larger than the degree in the denominator, therefore those no horizontal asymptote, or the degree in the numerator is going to be equal to the degree in the denominator, where therefore the horizontal asymptote is the leading coefficient over the leading coefficient. Or in the last example, the degree in the numerator is going to be smaller than the degree in the denominator, so therefore a horizontal asymptote is at y is equal to 0.